The idea with elimination is we need to have x and y lined up, same side of the equation, and we need a pair of opposites, which means we need one variable to be positive, the other one to be negative, of the same number. So we need a pair of opposites. So as we look at number 7, x and y's, they're lined up. They're all on the left side of the equal sign. And if I look at the y values, I know for some of us on our test, some of us really struggle with elimination because we made the problems a lot harder than they needed to be because we kept looking at x all the time. So I wanted to make sure the first example I did with you today to refresh on elimination, the pair of opposites was already there, but it's with the y's. So as I look at the y values, I have a negative 3y, positive 3y. If I add those equations together, what happens with negative 3 and positive 3 if I add them? We get a 0. Yeah, they disappear. They're eliminated. Nice. So that variable's gone. I don't have to worry about it anymore. So I still have to add everything else. Some of you with elimination are like, oh yeah, I've got my opposites. I added them. Oh, now what do? I have to add the other stuff. I have 2x plus, and there's really a 1 in front of that x. So we get a 3x. Whoa. Sorry, guys. Sorry, guys. My computer's not being great. I just restarted it, too. Sorry. Here we go. So we have a 3x. We still have our equals. 6 plus 12 gives me 18. So now I don't have a y value. All I have left is 3x equals 18. How do I finish this off for x? Divide by 3. Yeah. So my x equals 6. Now I have to find my y. So just like we did with substitution when we refreshed on that yesterday, now I need to find my y. So I've got to substitute that x back in, and you get your pick on your equation. With substitution yesterday, we had that nice circled equation that we said, hey, here's the easy choice, use this. With elimination, you take your pick. To me, when I look at this system, I have that second equation. It doesn't have any negatives. If I can avoid negatives, I might make less mistakes maybe when I'm doing my computation stuff. So if I were to pick a number 7, I'd pick the second one. But again, my only reasoning is it doesn't have any negatives. So it might make it a little easier. Maybe, maybe not. One of the big things we talked about yesterday was substitution. I can only substitute in for the variable that number actually equals. So that's an x. So it has to go in for x. So I'm going to have 6 plus 3y equals 12. If I substitute 6 in for x, I don't write the x anymore. 6 is in for it. Now I solve my little two-step equation. Move our 6. So we have 3y equals 6, and then divide by our 3. And our y equals 2. Remember, we talked yesterday, even though we're not graphing, it's still nice to write that answer, that solution, as an ordered pair. If you didn't do it on your test, or if you're going to retake and you don't do it on the retake, I'm not going to take points for that. If you show me you can do each of these methods and you can solve a system, I'm not going to get that picky on you. All right, so number 7, we had a pair of opposites. It was the y value. It was the y value in this case. It's not always x that you have to get rid of. All right, so now if we look at number 8, number 8 can be a little deceiving. I have a 5x and a 5x. So right away, when I give this kind of question, I have people like, oh, great. They're the same. I'm going to add, and I get to cross those out. And what do I get if I add 5 plus 5? 10. I get 10. I don't get 0. So I need to make one of them a negative 5. What can I multiply by to just make positive 5 negative? All I want to do is make it negative. Multiply by negative 1. It doesn't matter. I'm going to choose to multiply the top equation by negative 1. The reason why I chose the top one is because I know for some of you out there, the less writing you have to do, the more appealing things are. I get it. So when I go to rewrite that equation, I can just write it right below the second one. I can just write it right below there. So when I multiply by negative 1, all that happens is the signs change. So positive 5x becomes negative. Negative 2y becomes positive. And positive 3 becomes negative. I needed a pair of opposites. So I made them. I multiplied by negative 1. All it did was make the 5x negative, the negative 2 positive, and the positive 3 negative. That's all it did. Now, what I also like to do, I'd like to put a squiggle through the equation I no longer am going to look at. So then when I add these two together, I'm not confused by seeing 3 different equations like, oh wait, what do I add here? So positive 5x, negative 5x, they're going to eliminate for me. I have a positive 1y plus 2y, negative 9 plus negative 3. If you need to, guys, this is a great example of when maybe we might just want to double check our math with the calculator. Okay, I love it when you guys are doing mental math. That's awesome. I'm glad we're confident with that. But I don't know how many times I've seen something like this and negative 12 is written as positive 12. Or I have negative 9 plus negative 3 and people write it as a 6 or a negative 6. It happens a lot. So maybe just take a minute and just double check. To finish this off, we divide by 3. Now, pick whichever equation you want to find the x. I'm going to grab the second equation. I'm going to grab the second equation. My x and y, again, they're both positive in that one. So I think that one looks a little easier. I have y is negative 4. So it has to go in for the y. I can't put it in for anything else but what it equals. So I have 5x plus negative 4 equals negative 9. Nothing else changes but that y. Instead of y, I have negative 4. I don't put the y back in. Y has been replaced. All right, so then we solve. We add 4 to both sides. 5x equals negative 5. And we get x is negative 1. Again, writing that answer as an ordered pair, that's the preferred way, but if you've got x equals and y equals, I'm fine with that too. Works for me. All right, so in number 7, we started with a pair of opposites. We're ready to add. We eliminated. In number 8, we were close to having opposites. We had a 5x and a 5x. So to make opposites, we chose to multiply one of the equations by negative 1. Multiplying by negative 1 will just change your signs if you need that, if that's all you need. In number 9, now look at number 9. I don't have opposites right away. I don't even have 2 that are close. I've got a 3x and a 2x. And I've got a 2y and a negative 6y. So then I have to think about, well, what could I change those into to make them opposites? So if I look at the 3 and the 2 that are with the x, what could 3 and 2 both go into?
6.
They could both go into 6.
Wow.
How about 2 and 6? What could they both go into?
12.
I could do 12. Could I go lower?
3.
Can I go lower than 12?
3.
I could do 6. It's what they can both go into. So then you have your choice. You have your choice. Do you want to make the x's, turn them both into 6's? Or do you want to take the y's and turn them into 6's? What's going to be the easier choice? If I choose the x's,
What's so funny?
the x's are going to take a little more work. I have to turn them both into 6's. If I look at the y's though, one of them already is a 6. The y's are going to be less work because one of them already is a 6. So I'm going to choose the y's. It doesn't matter which one you choose. If you want to choose to eliminate x, you're going to have to do some multiplying for both equations. If you choose the y, what can I multiply the top equation by? So 2y becomes 6. 2 times what? 2 times 3. The 6 in the second equation is already negative, so I want to keep the top one positive. I'm going to go ahead and distribute. And remember, when you distribute, it has to go to every term. I'm going to write that right below down here. 9x plus 6y equals 24. Again, I'm going to put a little squiggle through that top one, just so I don't get mixed up seeing 3 equations there. (2x plus 9x gives me 11x. Negative 6, positive 6. They're eliminated. And then I have 42 plus 24 gives me 66. Divide by our 11, and x equals 6. You take your pick which equation you want to substitute back into. This time, again, I like to try, if I can, if there's an equation that has more positives than negatives, I'm going to choose that one. So whenever there's negatives, that's just a chance that I might get my sign wrong. So I'm going to pick the top equation. It was 3x plus 2y equals 8. I know my x, so the 6 has to go in for x. But it only replaces the x. The 3 is still there. The plus 2y is still there, and so is the 8. Nothing changes except for instead of x, we have a 6. 18 plus 2y equals 8. Subtract our 18. 2y equals negative 10, divide by 2, and our y is negative 5. So we have negative 5, 6 negative 5. There we go. So again, with elimination, you need all of your variables lined up though. X and y, same side of the equation. And then you need a pair of opposites. Sometimes, like in number 7, you already have a pair of opposites. Add, eliminate, and solve from there. In number 8, we were close to having a pair of opposites. We had a 5x and a 5x. So we multiplied by negative 1. So we got opposites. In number 9, we had to do some multiplying, so we turned both of our y's into 6's. It doesn't matter which variable you eliminate. Try to pick the easier choice. In number 7, it was y. In number 8, it was x. In number 9, it was y. So try to pick the easier choice. You can eliminate either one you want. Like in number 9, we could have chose x, but we would have had to multiply both equations instead of just one. So it's kind of up to you. Whichever one you pick, one might be a little more work than the other. It's going to be up to you though.